Bismillahirrahmanirrahim. Welcome back, my dear students. Today's lecture will be entitled Frequency Shift Keying, Modulation and Demodulation Techniques. Remember our last lecture in which we demonstrated the ASK modulation and demodulation, in which we used the logic levels in order to control the amplitude of the carrier. So if we use the data equals to 1, this means that data input equals 1, means that amplitude high, amplitude of the carrier is high, and if we use data 0, this means that the amplitude is low. In FSK, on frequency shift keying, we will use the logic level of data stream in order to control the frequency of the carrier wave. So if data will be equals to 1, means that the frequency is high, and if data equals to 0, means that frequency is low. We can use two ASK modulators in order to generate the FSK modulating wave. So first one, we have to use it by using a low frequency carrier, and the second one by using high frequency carrier. Suppose that we have a data stream to be transmitted 0, 1, 1, 0, 0, 0, 1, and 0, 0. This is the data to be transmitted for arbitrary value. So if we are talking about FSK here, if data stream equals to 1, means that the frequency is high. If data stream is equal to 0, means that the frequency is low. So if we are going to demonstrate this signal, this will be, in this case, frequency low. Here will be frequency high. And again, we are talking about low frequency. Here we are talking about high frequency, and we are talking about low frequency. This is the FSK modulated wave. In order to obtain this waveform, we have to use two modulators. One methods in order to obtain, or for obtaining the FSK modulating wave, is to use two different ASK modulators. First one by using a high frequency carrier, the second one by using a low frequency carrier. Suppose again this is the data to be transmitted, so we are going to talk about first modulator. I am talking about ASK modulator by using high frequency carrier. So the output for this case, we are talking about the same data stream 0, 1, 1, 0, 0, 0, 1, 1, and 2 zeros by using the high frequency carrier. So we will here, if we have the data stream equals to 1, this means that here we have a high frequency, and then here will be off, and here we have high frequency, and here will be off. This is the first modulator. Second modulator, we are talking about second ASK modulator, applying to it by using a low frequency, but we apply the inverted input, the inverted data stream, the inverted data stream. So we are talking about this data stream. If I'm talking about the inverted one, it will be equals to the same data stream. Here we are talking about 1, 0, 0, 3 ones, and 0, 0 we have here, yes, and 1, 1. This is the inverted one, inverted data stream. Again, we are talking about the inverted data stream. This is for the first case, we are talking about 1. Here we are talking about low frequency carrier. We are talking about low frequency carrier, then here nothing. Then we are talking about low frequency carrier, then we are talking about off, and here we low frequency. By summing first signal and second signal, by adding, we will get this one. We will get this one, which we measured previously. So we are talking about low frequency, and then we are talking about high frequency, then we are talking about low frequency, and then we are talking about high frequency, and then we are talking about low frequency. In order to get this function, this FSK waveform, FSK modulated waveform, I'm going to draw the block diagram which demonstrates this case. So I'm going to use two ASK modulators. First one by applying a high frequency carrier, and the second one by applying a low frequency carrier, but the input will be inverted. So first modulator, this is our modulator number one. This is ASK modulator number one. We have here the carrier input. We have here high frequency carrier, and we have here modulation input, and here we have the data stream has been applied, data stream. Then here we have the output for the first case. Then we have a second modulator, again carrier input, but we are applying here low frequency carrier. Then we have the data stream, but they are talking about inverted data stream. Data stream by applying it takes the first complement of it. Then we have here, this is the modulation input, and we are talking about the output here, applying to summing device. Then we are here having the FSK modulation wave. So it will get the first wave by using the high frequency, and the second wave by using the low frequency, and the summing will get this waveform. This is the frequency shift keying. Now I'm going to demonstrate the receiver of the frequency shift keying. The first part of the receiver will be PLL, phased locked loop. Going now to draw the block diagram of the receiver. First part will be our PLL. The input will be the frequency shift keying input signal waveform. Then we have here low pass filter. Then we have here voltage comparator. Then we have the final stage will be the word data out. Phase locked loop is a negative feedback system. We discussed this device. We use it in analog communication course. It's used for many applications, including synchronization, frequency division, multiplication, and indirect frequency demodulation. It converts change in frequency into change in DC voltage level. So the output here will be changing in DC voltage levels 1 and 0, but it still will have frequency carrier components. So we are going to remove the carrier components, the remnants of the carrier, by using low pass filter. The output is still rounded, so we are going to square up the waveform by using the voltage comparator. So the main function of the PLL to change the frequency change into a DC voltage change. Then here we have we have to remove the ripple or the remnants of the carrier, and the last part, voltage comparator, in order to square up the waveform. This is the receiver. The main advantage of this technique is the reliability in terms of data accuracy in the receiver. The main advantage of this system, comparing FSK compared with ASK, the reliability in terms of data accuracy in the receiver, but the price paid for that is more bandwidth. The bandwidth of FSK is twice the bandwidth of ASK. So more reliability, but the price paid for that is twice bandwidth. This is all about frequency shift keying. Our next lecture will be about phase shift keying. Enough for now. See you next time. Bye.